Okay, section 7.1, operations with functions. The hardest part about this whole section is just learning about the notation. All right, so it's not that what you actually have to do is difficult, but it's a little hard to understand the notation and what you're doing. And also there's a lot of X's that you get confused with sometimes. So focus please. And what does this mean? The f plus g of x that's how you read that, means the f of x plus the g of x. All it means is you add the two functions. This means to subtract the two functions, and order matters. So if it says g minus f, that's different than f minus g. Okay? F times g of x, that means to multiply the functions. And this one means to divide them. And then pay attention to the denominator because g of x can't equal 0. Therefore, you have to check if something is omitted from the domain. All right, so examples. If f and g are any two functions, then you can use the four basic operations to make a new function, h. So for addition, again, you're just adding. If you have f of x is 2x and g of x is x plus 1, the h of x would be 2x plus x plus 1, which you would simplify to h of x is 3x plus 1. What is the domain of that function? The original functions both had domains of negative infinity and infinity. They're just lines. And this one's a line too, so its domain is also negative infinity to infinity. Subtraction order matters. F of x minus g of x, the new function h of x, would take the f of x function, 2x, subtract from it g of x function, which is x plus 1. You must have parentheses so that you remember that you distribute the minus sign. So the new function h of x would be 2x minus x, which is x, and minus 1. Okay, don't forget you're subtracting both of those. So I already simplified it. The domain is still negative infinity to infinity. In multiplication of the functions, the new function h of x would be given by multiplying 2x times x plus 1. So that new function h of x would be 2x squared plus 2x. That still has a domain of negative infinity to infinity. But when we do h of x equals the f function over the g function, the new function h of x would be 2x over x plus 1, where x plus 1 cannot equal 0. Therefore, x can't equal negative 1. You solve. You subtract 1 from both sides. Now, since x can't equal negative 1, the domain is restricted. It's everything from negative infinity up to negative 1, but not including negative 1. And then you have to union that with everything from negative 1 up to infinity. So that's how you exclude the negative 1. Any questions so far? That says negative 1 to infinity. You good? Okay. I kind of squeezed it in there. Well, now we're going to do an example with some other functions. Now we have f of x is 2x cubed and g of x equals negative 6x squared. To add them, you just do 2x cubed plus negative 6x squared, which would be minus 6x squared. Done. Can't add them. You can subtract them. 2x cubed minus negative 6x squared, of course, would turn into 2x cubed plus 6x squared. And g of x plus f of x, we are changing the order in which we add. Negative 6x squared plus 2x cubed. But we would rewrite that with the 2x cubed first because we always go in descending order of powers. So notice that adding doesn't matter the order. Okay, adding is commutative. Remember that property back from Algebra 1. Subtraction is not commutative. I need it. Thank you. So g of x minus f of x is not the same as f of x minus g of x. So I subtract 2x cubed, and now I would rearrange it in descending order of power. Negative 2x cubed minus 6x squared. Notice that that's not the same as f of x minus g of x. It's actually opposite. We did not discuss domain and range on these. Next set, number 2. We're just practicing doing the operations. So now I'm going to take negative 2x, the f function, and add x plus 3 to it, the g function, and then simplify it, which would be negative x plus 3. Subtracting negative 2x minus, in parentheses, x plus 3. That would give me negative 2x minus x, which is negative 3x, and then you would subtract 3. G of x plus f of x. I'm adding again, except I'm starting with the g function, then I'm adding on the f function. That should come out the same as it did when we did f of x plus g of x, and it does. Negative x plus 3. Okay? No question. And then this will change. G of x minus f of x, starting with the g function x plus 3. Subtract from that a negative 2x, the f function. That's going to give us x plus 2x, which will be 3x plus 3. Okay, so far? Now, all of those, by the way, were linear. All the domains would have been negative infinity to infinity on them. Okay, but the next section, we got a little more thinking to do. What does a 1/4 exponent mean? You remember? Fourth, yeah, it's a root, right? The bottom number is a root because it's on the bottom like a tree. Okay, so this is the 4th root of x. Any restrictions on that? Can't do negatives, can we? We never did. We did find out that the imaginaries, but that was the square root of negatives. That had imaginary solutions. So, imaginaries are not part of functions domains, right? They're not. So this has a restricted domain. The domain for that function is only from, can you take the 4th root of 0? Well, the 4th root of 0 would be 0. I don't think your calculator would spit out undefined, okay? So it would be from 0 to infinity on that one. The first one, its domain is negative infinity to infinity. But if you're going to do any combinations, then what should the domain be? The most restrictive of the two functions that you're dealing with. So our domain is going to be restricted for these problems. Okay, so f times g of x. Well, we do 3x times x to the 1/4, and we have to remember the exponent rule. What's the exponent on x? 1. Okay, so we actually have to do 3 to the x, 1 plus a 4th. Remember, because you add the exponents, which would be 3 to the x, 3 times x to the what? 1 plus 1 and a 4th is 5/4. Okay? And it did say give the domain. Well, can I take the 4th root of 0? So is 0 included? Yes, it is. Therefore, its domain would be 0 to infinity. Now we got something even a little bit more restrictive. Because we're doing f of x divided by g of x, which means we'll have 3x on top and x to the 1/4 on the bottom, we have to pay attention to the fact that the x function, the x to the 1/4, cannot equal 0. You see what I'm saying here? X to the 1/4 can't equal 0. If you take both sides to the 4th power, x can't equal 0. We just decided, which just excluded even more of the domain. Now, we're not done with simplifying this yet, though. Can you simplify it? Well, what's the rule? When you divide like bases, you subtract, the exponents. So this is 3 to the x, well, 3 times x to the 1 minus a 4th, which is going to be 3x to the 3/4. But again, we had to realize that since we had put g of x on the in the denominator, that 0 got excluded from the domain, which means this isn't the correct domain this time. It's going to not include the 0, so it would just change by that much, where you put a curve bracket to infinity. Okay. Yes. Well, you know what your graphs are like. And I guess what I have to look at every situation individually. So to answer that, how do I figure out the domain? I cannot summarize that in one statement, because I have to look at each function and know the domain of each of the functions I'm dealing with. Now, how do I figure out the domain for each function? Well, if I know something's linear, you should know the domain's negative infinity to infinity. If it's a parabola, x squared, our quadratics had domains of negative infinity to infinity. Okay, our cubics, which we just started discussing, negative infinity to infinity. Most of them are negative infinity to infinity until there's something in the variable in the denominator. Or the roots. Remember, we did square roots, so we've already talked about those domains have restrictions. Okay, that's the square root function. I talked about that the whole way through the problem. That's okay. So what I did was I said the 4th root. Can you take the 4th root of a negative? That's what we discussed. I discussed in the beginning. So when I said the square root function, you can't. Only thing what we found out in the quadratic chapter is if you do square roots, the new answers for a negative. Remember, negatives were always excluded from the domain. Okay, that's why they look like this for their graphs. But we added in imaginary numbers. Okay, we learned about imaginary numbers, but that wasn't about a function. Now we're back talking about functions. Functions don't have imaginary answers. Okay, to be a function, they don't have imaginaries. Maybe that helps, I hope. I'll try to talk about it more as we go through a problem, okay? Now, the f of x equals negative 2x, that's linear. So is g of x is linear, right? So we need to recognize these as linear equations. So these both have domains that are negative infinity to infinity, okay? For both of them. Now, f of x times g of x would just be multiplying them, 2x times x plus 3. And then that would be negative 2x squared minus 6x. Now, that one domain would just be, because it's a quadratic, the domain was always negative infinity to infinity. Okay. F of x divided by g of x. Now we're putting f of x on top and g of x on the bottom. Therefore, I have a division by something. As soon as you put a function in the denominator, you must say to yourself, x plus 3 cannot equal 0. You solve it for x. X cannot equal then negative 3. Do you see where I'm getting the domain from now on this? I'm saying I can't have it be negative 3. Everything else is okay, except for negative 3. So then I go and say, well, from negative infinity up to negative 3, union with negative 3 to infinity. And the curved brackets means non-exclusive, not inclusive of those numbers, of the -3. Okay, we don't need to simplify this at all. It's done, right? So now we're going to do composition of functions. This is probably the most confusing part right here. So we're on 4B now, please. Suppose f and g are functions such that the range of g is a subset of the domain of f. What does that mean? It means that the f function has a domain and that the g's domain is part of the f function's domain. It might be all of it. It might be just part of it. Then the composite function f of g, fog, I was going to say fog. I know Ms. Hardy does not say fog. At least my student told me that he does not. And goff, when it's backwards. That O is not, it's an open hole. You see how it doesn't mean times, all right? That does not mean multiply. What it means is f fogging, f of g of x is how it's read, means do the f of g of x. What does that mean? It means plug the g function, well, it says that right there. It means plug g of x into f of x. All right, what gets confusing on these is there's lots of x's. Both functions have x's in them, so it makes that a little bit confusing. So hopefully you'll be focused here and go with me and practice this. So the new notation, fog, means the same as to the f of g of x. So whenever you see this, you can rewrite it like that if that helps you. Which means to put g of x into the f function. And g of f means put the g function into the f function into the g function. Find the f of g and the g of f, given that the f of x is 5x minus 5, and the g of x is 7x. And she says, like, going, oh my gosh, you said so many things about x. Well, sorry, I'll try to make it as simple as I can. Doing the f of g means do the f of, what is the g function? It is 7x. So we're going to do the f of 7x. Which means put 7x into the f function. Replace the x's in the f function with 7x instead. What the f function does is it multiplies its input by 2 and then subtracts 5. Our input is 7x. So we are going to be doing 2 times the input of 7x plus, oh no, not plus, it was minus, wasn't it? Oopsie. Minus 5. Okay, and we are going to simplify that. Now, I kind of wrote something over here and it got in my way where I want to write something now. So our answer to this is 14x minus 5. No, 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 no. Okay, no, I'm glad you said that now, because that's what some people will do. They will not take this x and substitute it. They will stick in 7x into 2x times 7x, and that's going to be completely wrong. Okay, you are replacing x with whatever you're plugging in. Okay, so I'm glad you said that, so that if anybody else was thinking it, we could try to clarify right away before someone starts doing that as a practice. Okay. I know that's confusing, and it's because all of these have x in them. It would be nice if this had a different variable, you know, and then you were replacing that variable with whatever this was. Okay, but we have to be able to read it. Now let's do the g of f, which means put the f function into the g function. The f function is 2x minus 5. So we're going to replace x in the g function with 2x minus 5. So we're going to be doing 7 times 2x minus 5. You are replacing the x in the g function with 2x minus 5. Then you'll distribute it and get 14x minus 35. They're not the same result. What? Seems simple to you? Or Okay, some people find this easy, and some people find this very confusing. So I'm sorry if I'm going a little slow for some of you. All right, one thing to be careful of, you cannot have a denominator 0. Okay, so where's that going to matter? Well, usually when we just stick something on the bottom. Okay, so let's try this one. We're going to do the f of g of x, or the fog f of g of x. That's how that one's read as well. So we're going to be doing the f of 2x minus 1. I'm going to go ahead and replace that so you can maybe understand it a little better. The f function takes its input and multiplies the input by 3. Our input is 2x minus 1. Okay, so replacing the x in the f function with 2x minus 1, we multiply by 3, and that's going to give us 6x minus 3. Okay. To do the g of f of x, we are going to put the f function into the g function. So in the g function, we're replacing x with 3x. The g function multiplies its input by 2. So we multiply 2 times the 3x, and we subtract 1. So I'm going to have to simplify that. That is 6x minus 2. Are we okay so far? Any questions so far? Cameron, something? I don't know. I have no idea where I got the minus 2. Thank you for saying something. I saw your face. I'm like, okay, so apparently I did something wrong, or he sees something. I want to know what it is. It's supposed to be minus 1, right? That was not in the parentheses. I think I must have multiplied it by 1, just like someone else might have done. It should be minus 1. 6x minus 1. Everybody okay now? Better? Very good, Cameron. Thank you for saying something. I don't know what I did. All right. Ooh, what's this? What do you think it means? Yes, it says the f of x. That's what it says. So whenever you see one of these, we're gonna fluff it. No, sorry, I don't want to say that. No, it's not. That's not what I want you to say. Gog and foff and all right. We're gonna put the f function into the f function. That's what it means. We're gonna do the f of 3x, which means we're gonna put 3x in for x. 3 times 3x. 9x. All right. Now the Gog. G of x. So G of x. G of x function is 2x minus 1. Okay, we're going to put 2x minus 1 in the G function. The G function multiplies its input by 2. So we have to do 2 times 2x minus 1. And then we got to subtract 1 at the end. All right, so then we're going to distribute and get 4x minus 2 minus 1. And our final answer, 4x minus 3. Are we okay? Okay, moving to another problem. More function operation practice. Here we go. F of x plus g of x just means to add the functions. X squared plus x minus 3. Can't do anything else. Now, it says simplify each and find the domain. What's the domain of the original functions? Negative infinity to infinity. X quadratic and a linear. This one is also quadratic, so the domain is still negative infinity to infinity. If we subtract the functions, x squared minus parentheses x minus 3, we'll have x squared minus x plus 3. Domain still negative infinity to infinity. If we multiply the functions, we take x squared times x minus 3. That gives us x cubed minus 3x. And you still have a domain of negative infinity to infinity. I could cube anything, right? Doesn't matter. There's no restrictions to what I can put in. Did I write something funny? Oh, yeah. I forgot the squared on there. How about f of x over g of x? This is where we got to worry. We have a function in the denominator. So we have x squared on top, and we have x minus 3 on the bottom. Whatever's on the bottom cannot equal 0. So x can't equal 3. All right, so the domain for this one is negative infinity up to 3, non-inclusive of the 3, union 3 to infinity. Okay, f of g of x. That means put the g function into the f function. So we're doing the f of x minus 3. We will be taking x minus 3 and squaring it, which would make us have x squared minus 6x plus 9. And the domain would be negative infinity to infinity. G of f of x means do the g of x squared. Put x squared into the g function, and you have x squared minus 3. Same domain, negative infinity to infinity. That's supposed to be a negative sign. Didn't come out right. Boosh. Okay. Oh, yeah, we're good. All right, after 11 comes 12. Here we go. Ooh, what's that mean? What? It looks icky. Okay, I have a question to pose to you. Put your thinking caps on. Look up here. F times g of 5. Well, either you multiply the functions and then plug in 5, or you plug in 5 first and then multiply the results. Which sounds easier? Good job, Cameron. Yeah. You want to know why? Look, guys, if you multiply these, you are going to have to FOIL it all out, and then you'd have to plug in 5. I think it'd be a little easier to plug in 5 and then multiply. Okay, so we're going to do the f of 5. So that would be 3 times 5 plus 2, which is 17. Then I'm going to do the g of 5, which is 5 times 5 minus 4, and that's 20 minus 4, which is 6. 25 minus 4, hello, which is 21. Caught myself. All right, now to do the f times g of 5, that's going to be 17 times 21. How many? 357. Okay. Now, if someone wants to multiply those out and test it, you can. That would be 15x squared minus 12x plus 10x, so minus 2x minus 8. And if you plug in 5, I don't know. Did I do that right? 5x minus 4. 10 and minus 12, yeah. All right, anyway. 15 times 25 minus 10 minus 8. Somebody do it. You get 357? We're all good. Okay, so now you believe me, you can do it the easier way. All right. I mean, probably didn't care if I proved it or not, but all right, f of g of x. That means to do the f of 5x minus 4. What does the f function do? It multiplies its input by 3. And the input is 5x minus 4, and then it adds on 2. So that's going to be 15x minus 12 plus 2. Final answer, 15x minus 10. Guys, quit making noises and stuff. Okay, f times g of 4, I'm going to put 4. I definitely want to do the f of 4 first because I've got to put it in the absolute value. 2 times 4 minus 1. That's 8 minus 1, so the absolute value of 7 is 7. And then the g of 4 would be 5 times 4 minus 4. And that's 20 minus 4, which is 16. Okay, so now I just do 7 times 16, and I'm done. F of g of x. Now I'm going to put 5x minus 4 into the f function. The f function takes the absolute value of its input. So 2 times, and subtracts, let's see, 2 times the 5x minus 4, and then minus 1. That's going to be 10x minus 8 minus 1, so minus 9. Absolute value of 10x minus 9. Well, not quite. Business, you got a function where f of x models the manufacturing cost per item produced, and g of x models the service cost per item. Write a function c of x for the total manufacturing and service cost. Both of them were costs. So if we want the total cost, what's c of x? We would add them. Okay, so you would add the two functions. I guess I could put that into the notation of the day. So you're going to do f of x plus g of x equals c of x. Anyway, we're going to add it. Add like terms to get 1,150 minus 0.011 x squared. Okay, I need your homework out on the side of your desk. You can start working on 5A, and I will also get you the worksheet if you didn't grab it off the back.